Hi, Yenner here, and today I thought I'd try out a video. I have built some electronic projects and showed them on videos before, but this time I thought I would try actually building one on camera, see if anyone would enjoy it. So the circuit that I've selected, which I don't know if I've ever even built this one, it's called a push-pull oscillator. And I'll see if I can get the schematic up there. So push-pull oscillator. So this is the schematic. Should be able to read that. It looks readable on my preview here. So I'm going to use the 201 electronics lab, which is the same as the very first kit I had when I was a kid. I don't have it anymore, but I managed to get one by Madtronics, makes them now. They still do have Elenco written on, like there's a sticker on the back of the book that says Elenco. But I don't know, it's weird that it's a sticker, but the one that's printed is now Madtronics, and the cover is a lot different. But the actual artwork in the book is the same, like the little guy that's the electronic lab guy. It's one of these guys holding a pen with the inkwell, which is pretty funny. So, I don't know, that I've seen, I think Dave Jones and Jerry Ellsworth showed theirs from when they were little, and it actually, like, the speaker looked different. On this one, the speaker's just in this vent, which is like the one that I had, which I had gotten from Radio Shack, or my parents got it for me from Radio Shack. But they had Tandy in Australia, so I'm guessing Dave got it from Tandy. Anyway, so it runs on 6 AA batteries, which the first 3 and the last 3 are connected in series, and there's also wires going to the center, so you can use the second 2 batteries to get 3 volts, the first battery to get 1.5 volts, and all 3 batteries using the first and last terminal to get 4.5. And then you can also put a jumper wire from the 4.5, I believe it's positive, going to the, yeah, because there's 0. Like it says 0, then 1.5, then 4.5 on these. Let me see if I can show. You got 0, and then 1.5, and then 4.5. So this one and this one uses 1 battery, this one and this one uses 3 batteries, and then these 2 will use 2 batteries. And then if you put a diagonal from this terminal to this terminal, then you can get your or even to these 2 terminals, and if you do the first and last, you'll get 9 volts. If you put the wire to this one, then you can get, and then use the first and last, you would get 4.5 plus 3, so that would be your 7.5. You can do 6 volts, so you can get you can use basically any number of batteries from 1 through 6. So, I mean, on the other ones where it has a breadboard, they'll just have 1.5, 3, 4.5, 6, all the way up to 9. But on this one, you actually have to wire your voltage. So these 2 battery compartments are separate. So if you have projects that only use 1.5 to 4.5 volts, you can actually just run it off the first bank. Which, I mean, they have you wired up like that anyway. I think at any time you don't need more than 4.5. You always use the first bank of batteries. So, alright, so let's see. I lost my page. Okay, here we go. Right to it. Okay. So I'm going to need to tilt the camera so you can see the project. I think I'll set it in this box to make it easier. Okay. So at the bottom of the page it has the wiring sequence. If it's a dash, it's connected. If there's a comma, it's not connected. And on the schematic, if you know anything about electronics, if two wires are crossing, if there's no dot on the intersection, then they're not connected, but if there is a dot, they are connected. So that's something to keep in mind if you're going to build one of these circuits on a breadboard or proto board, whatnot, or wire it up with alligator clamps. Let's see, just this little tiny tripod that's sitting on my CRT computer monitor. Okay. I don't know if that's too visible enough. I mean, obviously you're not going to be able to see exactly what I'm doing, but I just want to film it. Get it to go further without having it fall. Okay, that should be good enough. Alright, so the wires are different colors for different lengths. They're like color coded. Let's get some wires out and get the book. And the first set of wires goes terminal 17, 83, 95. So let's see, 83 is on the transistor, which these are, yeah, there two of them are PNP and two of them are NPN. And both of these arrows going out, I believe when it's going out, yeah, it should be NPN transistors. So 17 to 83. So 17 is here on one leg of a 1K resistor, and that's going to 83. Oh, this wire just isn't quite long enough, so we need, I believe, the blue wires. It's kind of awkward when that happens because then you got a lot more slack than you need when it barely doesn't fit. You got to go to the next size. So yeah, 17 to 83. So 17 is one leg of 1K resistor going to the collector of the NPN transistor. And then also from the NPN transistor, from the same pin, collector, we're going to go to pin 95, which is one pin of the 0.1 microfarad ceramic disc capacitor. It was 85, right? 95. Okay. So this is what I have so far. You can see the wires. That was the first set. Okay. Almost done with my SIG. Let me just finish it. Okay. Now next one is 18 to 50. So that's going to be the other leg of that resistor. And 50 is going to be an output transformer. I mean, at least another blue wire. Red wire definitely won't reach. So 18 to 50. So that's going to go from that resistor to this transformer on the top of the bigger coil, or at least the coil that has 3 inputs on it. So there's like a center winding, or a center pin going to the middle of the coil, and the other side's only one coil. And it says 900, which I believe is the turns, so it should be 900 on the side with the 3 pins, and then 8 windings on the side with the 2 pins. I believe that's the windings. It says it's 908. And the input transformer, which we're not using, has a 4K and 2K. I mean, I don't know if that's the resistance or if that's the windings. I mean, they look about the similar sizes. I'm not sure if the book specifies what those numbers mean. I would think it would be much bigger if that was the windings. So maybe that's the resistance or inductance. It's probably the inductance, so that's probably Henry's. Okay, instead of ohms. Anyway, I mean, the schematic doesn't say, it just says OPT for output transformer. But if you're going to build this circuit, then just know that the side with the 3 pins has 900 on it. The other side has 8, and it's a red transformer, so I'm sure Radio Shack or Tandy still sells them. You would want 908 either Henrys or ohms or turns, whatever it is. And it's probably Henrys, because I would imagine that they'd put the inductance if it's not how many turns, just to identify what it is in case you wanted to make the circuits permanent or whatnot. So just giving that information because I know it's not on the schematic, whereas everything else you could clearly have seen what is there. Although I don't know if the key icon is something that's on a typical schematic but it's a push button. So on the schematic, if you see that key, that's a little red push button, which is here. It's a push button. And there's also a selector switch, which is not used, only the push button. Okay, so for the antenna core, that one doesn't have any numbers on those coils. And I mean, the relay is just labeled. I mean, the transformers don't have anything written on them. Okay, so anyway, next set of wires goes 19, 80, and 93. So where's 80 is over here on the other transistor. And it's 19. Yeah, 19 is another 1K resistor going to the collector of the other transistor. And then 93, 80 to 93. So that's our other capacitor, which is a 0.05 microfarad. Yeah, I don't think we could do it with the white wire. I have to go with the red. So this goes to 93. Yeah, 93. So this is what we have so far. Okay. $20 to 52. Probably another resistor. Yeah, it's the other side of that resistor. And 52 is the bottom pin of that same side of the transformer, which is the input side because the speaker goes on the output. Okay. So it was 20 to 52. 20 to 52. Okay, so now that's how it looks now. You can, I don't know if you can see the numbers, but I'm just showing as I go. Okay, every time there's a comma, I'm just going to show how it looks. Okay, 29, 33, 51, 167. So first 29 to 33, probably use a white wire. 29 to 33. Yep, you can use a white one. It's good to use the shortest wires possible to reduce the resistance, and also, not that it makes that big of a difference, I suppose, but it's better to have extra of the long wires than a shortage, especially when you're building really big stuff on this thing. Because in the beginning of the book, there's a roulette you can make using the flip-flop and the NAND gates, and it's like 300 wires at least, and I think it's that big. I built it once when I was a kid. It takes hours. It uses up so many wires. I think I even had to add wires to it when I built it when I was a kid. And the whole thing just looked like a mess. Yeah, it's crazy. A lot of connections. And it doesn't show the schematic on those earlier projects, and they're the most complicated, which is very strange. It's like they're just showing this is what electronics can do, and now let's start learning it later in the book. And then you start building, push a button and a light comes on circuits after you just built the most complicated ones in the book. Okay, so 29, 33, 51. Okay, so 29 to 33 was going from a 22K to a 47K resistors, and then we need to go to, what was it, 51? Yeah, 33 to 51. That's the center pin on the transformer. You use a red wire. 33 to 51. And then from 51 we're going to, I believe, 167. And 167 is probably the button. Yes, it is. So the center pin of the transformer is getting connected to the button. Here is the button. 167. Okay. Update. Okay. 30, 79, 96. 79 is probably the speaker. Is it? No, that's 174. 79 is... Oh, it's the transistor. 30 to 79. So the other side of the 22K is going to the base of the second transistor that we hooked up. From 79 to 96, which is the other end of the first capacitor. Use a white wire. Okay. 30, 79, 96. There's update how it looks. Okay, and then 3482.94. 3482.94. 34 is the other side of the 47K. What was that, 82? Yeah, 82 is the base of the first transistor. And that was 34 to 82 to 94. I just check a lot. I don't want to have miswiring, so I constantly check and check and check. So, okay, 82 to 94, right? Yeah, 94. It's good to always double, triple, quadruple check, because if you hook something up wrong, you can blow things out. Not a good thing, and it's not going to be too easy to replace them on this thing. I mean, it can be done, but especially if you blow out the chips. If you blow out the chips, you're going to have to get some perf board or try to desolder these. They're soldered to a PCB, and then there's a bunch of pins going from the PCB to the springs. So it'd be quite a mess to fix that, especially if the solder pads break when you desolder it. So you'd have to get some perf board, do a bunch of jumper wires. It'd be a mess. This circuit would only be the transistors, maybe. And it's only running on 4.5 volts, but you always want resistors, I believe, on the bases. So you don't want to hook the voltage directly to the base of the transistor because you don't want to blow it out. And okay, so hook that up to 94. Okay, so here's a view again. And then we're almost done. Only a few more segments. 53 to 173. So now we're going to probably have to use a yellow wire because we're going, I don't know, blue should reach. 53 to 173. The top pin of the second coil. .173. So we're just connecting one side of the transformer to the speaker. Then 54 to 174. It's just the other side of the coil going to the other side of the speaker. Okay. Some more segments. 58, 84, 81. 58, 84, 81. So that's the batteries. I guess I was wrong. They use, on this one they're using the bottom bank. Not that it particularly matters, but anyway, 58, 84, 81. 58, 84. So we're hooking ground to the emitter of the first transistor. 58 to 84. And then jumper over to 81 to hook the other transistor to ground. So that's our ground connections right there. Is that all this? Yeah, I guess that's all that's connected to ground is the emitters. Then we got 60 to 168, which is going to be our power delivery to the push button. 1.4 volts, or no, 4.5 volts over to the switch. So those last ones were just for the power. Okay, and I'll give you guys one last look at this page. We did number 62, push-pull oscillator. Okay, should be able to hopefully read that. I mean, if you can pause it to read what's there if you want. The bottom is the wiring sequence if you happen to have one of these, which you would be able to just follow along in the book anyway. So let's see what it does. That's not very impressive. But it did say that we could, it says you can hook up different capacitors and different resistors and see what happens and take notes. And so yeah, we can make different tones. So we can move two wires. It won't reach. Put another jumper over. That does nothing. Came unhooked. An annoying noise to annoy people with! Yay! I swapped the 0.5 microfarad for a 0.005 and the 0.1 for a 0.01. So it looks like when you decrease it, it gets to a higher pitch. Then the resistors, it said if you switch the 47K and the 22K. Okay, so here's the 47K, which has a couple of wires on it, and the 22K is over here. Let's give it a bigger 470K instead of 22. Let's see what happens. Oh wow. So when you increase, it seems if you increase either one of them it lowers the tone, and so I'm guessing if you increase either one of them it'll raise the tone. So let's change the 47 to a 4.7. Quite reach. There we go. So the bad thing about these kind of projects, I usually tell you in advance so you know to put a slightly longer wire on the ones that you might want to change. I mean, you can read it first and then know that, but yeah, they ain't doing anything. It's just clicking when I release. Okay, so let's move. Yeah, that didn't come unhooked, so let's move 470 to a 10. So now instead of the 22 we have a 10, and instead of 47 we got 4.7. Wow, that is high. Can you hear that? It's like a dog whistle. That is really high pitched. Okay. I should have built the one before it, because the one before it had used the variable resistor, and that would have probably been more entertaining because I could change the tone at will without having to rewire it. But this is my first time like building something on camera, and hopefully you all enjoyed it as much as I did, because this stuff is fun. It's fun to experiment and create, especially with computers and electronics, which is what makes microcontrollers so fun, because all the wiring you have to do on discrete logic like these, if you want to change something, you have to physically remove wires. If it's a breadboard project one, you have to change components and move wires. Whereas with a microcontroller or a Raspberry Pi or Arduino, if you understand the concepts of the code, or you can research concepts on demand, you can just change a value. Like if you're using the tone library, you change a number and re-upload it, it changes the tone. You want it to beat different speeds, you just change the speeds in the program, the delays or whatnot, or note durations. Like with LEDs, if you want to change how quickly they blink, how long they're on, how long they're off, how rapidly that transition is going to happen on the whole speed of the project, you got to change resistors, capacitors, instead of just changing a number. So it just makes things easier. Not to mention, if you wanted to make something from scratch, it's a lot more difficult with these type of components, but when you have a book and a means of experimenting, it can be fun to just experiment with what's in the book. But designing things from scratch, you really need to understand this, and that's what this is for, is to teach you that stuff. But even if you don't go that far, it's still fun to just hook up the wires, and this thing does 200 different things. So, and then it's like, if you really like something, then now you know how to make it, and you can make it yourself, or you can decide, I want to shrinkify it and make it easier. You can learn how to make the Arduino do the same thing and get a clone Arduino for about $250. Power it off of a USB cable or a 9-volt battery, and you're all set with that. So I hope you enjoyed this. Be sure and leave comments below if you have any questions. I don't always, a lot of times when I'm interacting with YouTube, it's on my Xbox, so I don't actually see anyone's comment boxes or annotations. But when I go, sometimes, when I go to upload a video, I might notice I have notifications. So if I happen to check and I see I have a comment, if I can answer the question, I try to do that. I have had times where I didn't know the answer, so I didn't respond, or I had to tell people I don't know. I don't really get a lot of comments because my channel is still really small, mere couple, like 22 subscribers. So I don't know how many people are going to see this, but when I made my last couple projects and just showed them off, in the last year they've gotten in the 5 digits views. If you're still watching, good for you for putting up with me for this long. I know that some people can find my voice unpleasant. Nothing I can do about that. I'm sorry to those of you that don't like it. Sorry for the crudity of the videos. If I can get more subscribers and actually start earning some more than 3 cents, then I mean, I would obviously make a career out of this and buy some equipment, get some better, like get an actual camera rather than my $30 Windows phone, and use something better than the clip off of a selfie stick that happens to fit my little tiny 10-year-old or however old tripod, little tiny tripod that I had gotten from my my old Kodak Easy Share. I still have my Digital Concepts little mini tripod, and my mom got me a selfie stick as a joke because she knows I think that people on social media non-stop can't even focus on anything because they're just on their phones. I laugh at that stuff, and I saw a commercial where someone had a selfie stick, and I was just like, oh my god, they actually make that crap. And then I kept saying they were stupid when I would see them at the store, and then she got me one as a joke. But look, I noticed that it unscrews, and it happened to be threaded to fit my tripod. So I was like, now I could actually set up the timer, put my phone and adjust the angle. Obviously you gotta put it on a table or something because otherwise it's on the floor, but you know, it would be nice to get, you know, a yay high tripod and a camcorder. And if I do get one, and a better computer so I could do better video editing, that would also be, you know, if I could make money doing this, I would gladly make better quality content. But until then, it will be what it is. I record on Twitch using the Kinect when I do my gameplay, and I use my phone when I actually make videos. So that's how it is for now. I don't know if I'll ever actually be able to make a career from this, but I've been rambling for a bit too long. So if you're still watching, I really appreciate that. And make sure to subscribe and like my channel. And if you want me to build more, I don't know that I'd have the patience to do all 200 projects, but if you'd like to see more of me building projects on here, if you liked how I did this, I would be more than happy to do it. And then obviously if I am successful and get more money, then and I get a better setup, then I could obviously be able to have a much better resolution, have it actually point at the project while I build it so you could see better. And I'd also probably start using my other kits that I have, the breadboard ones, and it just depends if what kind of response I get from this video. So please no trolling. Don't talk about my looks and my weight because I'm just gonna ignore it, and it's not constructive criticism. Just messing around. I believe in freedom of speech. You can say whatever the hell you want. Anyway, hope you liked the video, and hopefully I can make some more like this, and hopefully people will enjoy it, and just have a good day.